Welcome to another episode of my podcast. Today, I have the honor and pleasure to talk to Carolyn Ristau. She is a cognitive ethologist, worked with Donald Griffin, who is the discoverer of bad echolocation and the founder of the field of cognitive ethology. And she's written a biography about him. It's a pleasure to have you on this podcast.
Oh, thank you very kindly. It's very nice to be here. I'm honored by your asking me.
Yeah, I had the pleasure to be in contact with you during my PhD. You read parts of my thesis and gave me feedback. And in fact, my book that's based on my thesis, I have a nice blurb by you on the back of the book. So it's great to
Oh,
talk
that's
to you.
fine.
Now your own book is ready. Um, I think it was released only a couple of days online ago. Perhaps you can tell us
Yeah.
a bit about it.
Okay. Well, I see it as far more than a biography. It's a history of science because, as two former students and colleagues of his, Jack Bradbury and Tim Williams, kept telling me, they offered and they plowed through the whole book with me as I was writing it, making suggestions. It's not supposed to be about everybody else. It's about Don Griffin. Well, no, he lived in a world. And I wanted to explain the world about him and the fascinating intellectual environment he was part of. I thought that was very important. I wanted it to be a broad view of science in that time. And in fact, I've had some very nice comments about by Andrew Rowan, who's the editor of the Well-Being International Studies Repository, or just look up wellbeing.org, which is hosting the book, basically saying how it's giving an intimate look in how science is really conducted, day by day stuff. So I see that as a part of it. So hopefully far more than a biography, and also a look at, importantly, what led to the development of his various projects and his thinking with finally being cognitive ethology. So that's simply the one word biography and an explanation. You got to be careful, very careful of interviewing past teachers and lecturers. We're used to 50-minute spurts. So, okay.
Yeah, and your book has 3 volumes.
I know. Well, and yes, it's long. But when I couldn't find a publisher, because they all told me the same thing, a biography. Biographies don't sell. Either it's somebody very famous, everybody knows about, and there are lots of biographies out, or the world doesn't know about it, and then they don't sell. So I figured, after so many book proposals, I said, I'm going to write what I want to write.
Yeah.
That's it. I'll publish it myself. And so far, it's gotten a fair number of compliments. Admittedly, my colleagues and friends and the editor, so maybe biased, but hopefully so. But it encompasses different phases. I mean, I think, I interviewed 40 people for this biography, mostly colleagues and friends. And they would often tell me, even though I was asking about Don Griffin's work, they tell me about their work at some considerable length. And what I kept finding out was how so much of it seemed to start, really, the essential ideas when they were young, when they were kids, what they chose to play around with, what interested them. And I think that's so important. As I keep browbeating my own grandchildren, trying to encourage what they should be interested in. And so with Don Griffin, he was fortunate to grow up just almost all his formative years in a small town, still exists, still a lovely place, Barnstable on Cape Cod in Massachusetts. The sea was not far. There were marshes all about near him, meadows to walk in, isolated from other kids. So what he had were what he could find walking around, the animals, and they were very important to him. Early on, he kept a journal and he would collect animal species. Unfortunately, he thought he wanted to grow up and be a fur farmer and a hunter and a trapper. That did change, but at least there was the interest in animals. And his parents were incredibly supportive. He called them indulgent. And P.S., before they lived in Cape Cod, he lived north of New York, a place called Scarsdale, and his parents would literally drive him to the river, the Bronx River, and wait in the car while this little 7-year-old or 8 could fiddle around and explore. I mean, that's a lot to do.
That's wonderful, yeah.
And on and on. So they also did not want him to become a fur trader. He didn't, but that was probably him. I don't know what impact that had. That particular wish had, because he certainly kept, despite their admonitions, buying traps surreptitiously and things like that out of his allowance. So that was very important. The fact that there weren't other children around, which I mentioned, that was important. So they were there. And the fact that they were very concerned for his safety. So they wouldn't let him have a bicycle. That was too dangerous to go out on the road. They wouldn't let him walk to some other distance to some other child's home. Well, they were all far away, actually, in most of his growing up. So, but he was allowed to wander around in the meadows and all. That was, and even to go sailing at age 10
Wow.
and 11.
Yeah.
But again, it was a protected bay there, and all the children around, went out. And there's an anecdote. Please stop me if you want to direct me.
No, I'm very interested.
Because there was an anecdote of a storm coming up, and he was a young teenager, and he'd had another child in there with him, and some woman said, "Oh, you better get in touch with your mother. It should be so worried about you that, the storm here." And I said, "Oh no, she'll think I'm too sensible to go out in this." So, so he would do what he wanted. That there was certainly that spark to him. But by the same token, he was told tales of his ancestors, who were very accomplished people. And I have a whole sections about the ancestors, both in the arts, photography, some in business, scientists, Alfred North Whitehead, Clarence Redfield, Clarence Redfield, Alfred Clarence Redfield was a famous marine biologist. His Uncle Alfred, took him even on some research walks where he studied the marsh and the past evolutionary history of the marsh with core samples. So
they got an early exposure to evolutionary theory.
Yes, he did, in a very personal way. And but the sense of accomplishment, and many of these people worked hard to do things as well for society, to apply what they'd learned to the grander world. So a very humane aspect, but hard work. And his background there was in Cape Cod. That whole Yankee area was very, very conservative and restrained, a restricted kind of person in the sense of how you express yourself, polite. And so that was part of him too. In fact, a comment from someone who knew him well said, "Yeah, he grew up in a Victorian atmosphere." And so there was what was proper and what wasn't to do. So this was also part of this man. But I think the curiosity was fostered, and that was so important. And so he went on to banding bats. He banded 16,000 of them during his high school and college years, persuading others to join him in what his second wife, Jocelyn Craig, called his Tom Sawyer fence washing technique. Isn't it interesting to be doing this, to be washing the fence or to be banding bats? So and in the field of animal behavior, unfortunately, even now, there isn't a lot of money. We're the poor relations. Neurobiology is where it's at, right? And so you're always, in my experience, I guess you're operating on a shoestring, and you're having volunteers, and you're having ill-paid undergraduates and such working with you. So this charm, and he was a charming man likewise. He was a raconteur from
Hmm.
early on. Many tell of, as you go on long drives, to wherever the field work was taking you, they'd be entertained by all his stories. So, and there are some in the book. I was fortunate enough to be
Hmm.
able to include those. So, okay, yes, he gets to um, Harvard. Oh, before that, he's home tutor for a while. His father
Hmm.
is a very good writer, was a journalist, and then an ad, and had to retire for health reasons. All this being in Cape Cod, and for a while he goes to the local school, but things like, oh my gosh, the question of evolution comes up, and well, says the teacher, can't do you want to imagine your aunt was descended and yourself too from an ape? That kind of attitude,
Yeah.
which did not go well with his parents. So they
Hmm.
tried a Tabor kind of academy, which was a private school. It was expensive, and the parents didn't have that much money. As it turned out, they were eating into their savings a good bit to educate this
Hmm.
son they were so devoted to. And then they were worried, and he also, whenever he'd have a cold, they decided it was pneumonia. He'd be pulled from school. And so finally, he was educated at home, primarily by his father, but in the fields that his father wasn't comfortable, they hired a tutor. And so he got to roam a good bit of the day into the fields, more about animals. So that was absolutely delightful. And few said the family, he did make it into Harvard. That had to happen from their point of view. And that was where he didn't do well in physics. He got a C, I think, which has
Hmm.
some impact on things because he probably he was very curious, remember, about bats, because
Hmm.
also in his days of banding birds, he then switched to banding bats. This too was rather amusing because he just used some old bands that he asked for from the government. They gave it to him, said what they were going to be for, but it turns out they were duplicates because they were discarded. Nothing much wrong with
Uh,
them,
yeah.
from birds. So now flying about the world were identically labeled bats and bands, which infuriated the government officials. But he said, well, anyway, that got ironed out, but that was during high school. So he has a knowledge of bats, and they communicate. They make high pitched sounds, very high pitched, although also some lower ones, both for communication and what more, he wondered, because they could fly in the dark. Now, this had been discovered in the 1600s by a monk called Spallanzani, but it was buried, it was forgotten. It was said, ridiculous, can't be, it was just ignored.
Hmm.
And so the papers were there, but they were not available to anybody at that point. Um, so the physics is important because he suspected very high pitched sounds might be involved. Bats have very big ears given the size of their body, so that's a good kind of guess. So he and a friend Galambos conducted some experiments, and with trepidation, especially because of the C in physics, he approached the one man in the world, Pierce, who had designed this instrument which could capture these very high pitched ultrasound, we call it, or supersonics, they called it, and they could be recorded. They made marks on a rolling drum so you could see that there was a frequency. And he agreed to lend it to them on their own. I think this so impressed Griffin. I think that belief in that trust was
Hmm.
very important to him and his attitude. He let me a sailboat. He let me all sorts of things. He finally took it back because I couldn't handle it.
Well, it must have been
Because
a
he said,
very
"No
significant
territory."
moment in his life. I guess if
Yes,
that hadn't happened, maybe none of his other achievements would have followed.
could
Huh.
well be.
Huh.
And so they lent them, and they could record it, but not as the bats are flying all around. And they're pulling their hair. How can this be? You know, and then finally they realized the bats were emitting highly directional signals, concentrated in one focal direction. And likewise, the recording device, this great big round horn, was picking up highly directionally. So unless they were perfectly aligned, unless the horn was right in front of the vocalizing bat, you got nothing. All right, so that was a big setback. And then the question was, how do you prove that they're using it for echolocation? Well, he didn't make up that term quite yet, but and they didn't feel that they had the data. So being good conservative behaviorists, the bats made these high-pitched sounds. They didn't quite know why, and they're above most human hearing. And maybe they're for communication, don't know. But they didn't really believe that. But to publish something and be precise and in a tiny bit of space, that's what they did. And so it went on. There's this pressure to do something sensible for your PhD. He studied bird navigation, which seemed to be, more precise. Galambos went on to study the neurophysiological basis of the bat sounds, which turned out to be a very good choice, because he could find for his thesis that the bats were receptive, which makes sense, to the very range of sounds that they were producing. And nobody had believed that or known of that before. So, and he continued such studies the rest of his life.
That's interesting from our modern perspective to look back and think that scientists were extremely skeptical about that whole endeavor, that bats could make these sounds that no one can hear, and then that they can operate in the world with them.
Yes. And furthermore, at the point when they were saying they are using this for navigation, as they did more experiments, one of the big masters of the field came up to Galambos after a talk, because they'd switch off who gives the talk, and shook him and said, "You can't possibly believe this. How do you say that?" So there was hostility throughout Griffin's entire life to his ideas. Entire. Then he was studying bird navigation, and the belief at the time, you find the silver bullet, you find the one stimulus that's responsible. Well, gradually, some people, Don certainly, and a few other scientists said, there's not going to be one. There's going to be a lot of factors. Don was supposing, well, maybe the birds are paying attention to the fact that this is a coastline, to other objects along. Nonsense. So he continued bat navigation studies throughout his life. He was highly resistant, even to the end of his days, about there being any magnetic perception. He said, okay, show me the sensing instrument, show me, the neurological function, the neurological structure that allows this. And of course, at that point, they hadn't. And even now, there are quite, I mentioned some of these theories which involve quantum mechanics as to how magnetoreception occurs, which it does occur. It's been found quite widely. All right, so now we've taken him through college. He's met someone who also wants to go into science, Ruth, and their marriage and he the war breaks out. He has a job in military research at Harvard in Smitty Stevens' lab, very important in the history of behavioristic psychology. And he learns, fortunately, on this and some other war-related research, which fortunately keeps him out of actually having to take a gun and fight in the war. His brain might be useful. He learns about radar, he learns about instrumentation, all of which was very important for his later work. Okay, so he's still interested in bats. He does a little bit of side work with bats. Finally, he gets his first job. He's been a Harvard Fellow. That's very prestigious, and you don't have to you have fewer requirements to get your degree.
To interject here,
sure.
one interesting anecdote I heard about Griffin was that during the war there was a funded project to potentially use bats to transport bombs.
Oh, yes. I was going to avoid telling that story because it came so much. It was actually later, but it was during the war. Oh dear, he was approached to take part in this. So somewhat reluctant, but he did it, and he tries out some bats and has them carry the smallest little incendiary device. It was supposed to set a fire, at a certain time. And I says, no, they can't carry it. It's too heavy. It's not going to work. That's okay. Everybody ignores him. He thinks the project is dead. He doesn't realize they're ignoring him. Somebody's got an in with Eleanor Roosevelt, who has an in with her husband, the president. And so, yes, the Bat Project continues, the event being the test. It stumbled around a good bit till I get to this point. The idea was the bats were going to go out, fly into they thought all the houses in Tokyo were wooden structures, which it wasn't. That's how much they knew. And the bat would roost in some of these, and at a predetermined time, the incendiary device would go on fire, burn down whole swaths of Tokyo. Okay. So they tested out at some airport where, in what bats do is they go back to their roosts. They don't just go any old place that you want them to. So some of them escaped from where they were being held.
Yeah.
The test wasn't officially supposed to start yet, but all the bigwigs are there. And they decide to go back and roost. I think it was by the general's house, which thereupon somehow blew up his house, his car, the hangar, and there were pictures, and it made all the newspapers, and Griffin's name keeps being associated with it, much to his chagrin. So I'm very sorry, but it's out there again.
Yes, it's hard to avoid that, I suppose.
That story gets around. Okay, so now we've gotten him through. He's in his first job.
His first job, yeah.
Yes, he's mostly studying bird navigation still. And he's chosen finally after various, this fun, because along the way, in fact, during his PhD, he's worked with storm petrels on Kent Island off the coast of Maine. So if anybody wants to wander around, it's still overseen by Bowdoin College. It's a research station and has flourished. And so many funny tales from that endeavor. But rather than go into detail, when he's at Cornell, he's now deciding, okay, I'll get bigger birds to follow because they are very difficult to see. He's trying to determine their vanishing point. Do they know where home is when you displace them and then set them free? And so, okay, still the same problem. You have spotting scopes, you have whatever, they disappear. So he decides, okay, there's the way to do this. I'll learn to fly. So he learns to fly. In fact, all this I did begin a bit earlier while I was at Harvard as a fellow, but the main part was in Cornell. And so he's did many studies with that. And some of his difficulties, either with returns, which he continued on in the job at Cornell, is that the birds were taking too long to come back. It didn't make sense. He knows how fast they fly. What are they doing? And when they leave, they don't necessarily, go off in a straight line towards where they're supposed to be going. What's going on? Well, modern day technology, that's another point to raise, how throughout his and so many of our careers, it's the technology. You have a great idea, and then the technology isn't there to help you deal with it. Now, there are tiny little devices, GPS devices, that also indicate how, if the animal has stopped, say the flying seabird in particular. So you get information back about the where they went, how long they stopped. And it turns out, hey, they stopped to eat a lot. That's why they're not going, they don't go straight away. They're going to be headed. This is a nice, tasty place. Furthermore, indeed, at the beginning, they're zigzagging, which absolutely confused Griffin and others. But what they're doing, as has been studied by some, is trying to find if they're, for instance, one of the highly olfactory sensitive seabirds who depend on fish for their food. They are trying to find the odor plume that arises from some of the stuff that the seabird is eating, the plant life. And the best way to find that is to cut across, because apparently there are some not just wide dispersal, but often some direct plumes. And then the bird follows that plume to their feeding site. So again, modern technology found that out, and how you could do before. Okay, here we are. We've gotten to okay. Finally, he's heard from a 1880s, I think, journey of von Humboldt in Venezuela, a report that there are birds that may be echolocating. Very intriguing. So he sets off to study birds, these very birds in this very cave. Again, fascinating stories about this, because he's in part funded by a very wealthy man who is very interested in birds. And so they find indeed and record echolocating birds. These birds nest deep into the caves or at the edge. And as they approach the cave at night, because they are out foraging, they make these sounds or whenever they approach the cave, because it's dark inside. And they're very different from of course, the bat sounds. They don't forage as bats do. Bats are so good that they can catch tiny insects. These birds are just trying to get to their nest. And it's interesting because the better echolocators are the ones deeper in the cave. And why are they deeper in the cave? Because, hey, if you're a bird, it's a nuisance to go all the way in. But they're very delicious, as they are, according to the local people, as they are young. When they're young, they're full of fat, and the fat, so they're captured and used. So the birds kept receding over thousands of years, further and further into the cave, which then impacted on the needed echolocation skills.
Wow.
So,
yeah. Perhaps human selective pressure there on the evolution of these birds.
Absolutely. That's how it's generally interpreted. Okay, so Harvard, I've given you hints of what he did. He, at this point, the environment, mind you, he's chair of the biology or zoology department, as it was called at Harvard. There's another term for someone who is, in effect, you can have two positions. You can be an elected chair and you gather everybody's opinion, or I'm forgetting the proper term, almost dictatorial powers, just because you have that kind of power as head. He didn't have that kind of power. And there was a rising sentiment among molecular biologists that this stuff that Griffin was doing was pure nonsense. He and E.O. Wilson as well, who was a naturalist studying ants, and one of them, for a joke of sorts, found an old, from his teenage years, paper he'd gotten published about the contents of seal stomachs, and sent that out as his publication. It was just kind of harassment. Then he was offered, and I'm skipping off over the whole time. That was very important. Lots of interesting work, lots of interesting anecdotes. This time down in Trinidad at the Simla station, run by William Beebe, the famed naturalist, whose main, well, they didn't like to say it was companion, but person who co-ran the station was Jocelyn Crane. They first met there as Don went down to study fishing
Hmm.
bats. Another problem: how in the world does a fishing bat catch a fish? Because of all the refraction as
Right,
even their
yeah.
sounds would enter the water, and then again as they come back, and that's what if the fish is moving too, as fish tend to. So that's another whole fascinating story. I won't give you the answer to that one. But anyway, he meets Jocelyn, and it looks like they are immediately smitten. He,
Hmm.
but she stays, and well, not really actually. What happens is immediately they have the people at the station have a really refined lifestyle, both because of William Beebe and Jocelyn. They have dinners each night on nice tablecloths. They have uh, a little silver bell that calls them to dinner. Fine food overseen by
Wow.
Jocelyn.
Yeah.
Um, but you have to dress appropriately for dinner. Oh, and the cocktails that precede dinner, in which much scientific discussion is supposed to be happening and does. But it's an important, convivial, elegant kind of scene. And alas, here comes Griffin, and what does he have? A very smelly fish pond. Those odors come wafting into cocktail hour. Uh, Much displeasure. Beebe doesn't like it. Jocelyn doesn't like it. They say so, and Griffin moves the fish pool someplace else. So that was actually their first impression, not
Hmm.
instant anything, if I have to be correct about that. But anyway, uh, at this day, he does get divorced from his first wife, but this is after Beebe passes away, which is a few years later,
Hmm.
because Beebe is quite old, and it's really Jocelyn who's been managing the station. But it sounds lovely. I want to go to Trinidad, but apparently it's quite different. The station is really suffering now. It doesn't have the proper financial support.
Hmm.
So he's now been invited after this has been going on. He's at Cornell. He's been invited at Harvard. He's been invited to start a new Institute of Animal Behavior Research at the Rockefeller University, which he does, and he and the president, Detlef Bronk, managed to persuade Peter Marler, very well-known ornithologist and study of bird song. In fact, it was he and his team that have shown how the young birds go through very similar stages of song development, if it's a songbird, as humans do in language learning. Having babbling stages, crystallization stages, and learning your dialects, which matter much for their reproductive success. If you're a bird, I don't know. I married an Englishman. He gets me annoyed by trying to do a Brooklyn accent, but he doesn't do it well. All right, so we have the Institute of Animal Behavior. He's still carrying on both work with bird navigation, with bat studies, and with the question of animal awareness. That's by
Hmm.
1976, that little book. And it was the particular timing of it seems to have been promoted by the fact that Thomas Nagel was there on sabbatical for a year. And they got into various intense discussions, very nice discussions. But Nagel's point of view was, oh yes, bats may well have mental internal states, but we can never learn about them. We're third person. The state is a first person experience. So that's that, And meanwhile, uh, Griffin was saying things like, look, humans can echolocate, which they can to a very limited extent, which gets better with training. And I think he says he managed to get Nagel to put a footnote in about that, but he did not persuade Nagel of anything. And
Hmm.
yet, since that time, a lot of research has gone on about trying to understand what the bat is analyzing. And indeed, different bats, depending on their niche, are analyzing different aspects. So they're constructing, the current idea is they are with their echolocation, constructing a three-dimensional world. It has surface characteristics that they can determine. They know the location of items, that they can focus attention, and it's this ability to go to one thing or another, which lends to the evidence, that this is purposive behavior. Okay, so that is not well accepted by most people. In fact, a person called one of his later books, which just develops these ideas and develops examples of the kinds of experimental evidence to support it. One of such book has should be called, says the noted experimental psychologist, the
I think the satanic versus
of animal behavior after Salman Rushdie's book. So that was the kind of attitude that he and I remember being in the lab. I was initially hired. I'd been in Peter Marler's lab, and Griffin needed someone to work with. It was as I remember, it's a half-time position. But I had 3 children, and a half-time position was excellent. And worked with him on some of the indices, and then doing my own research work, which he was very supportive of. So I saw the kind of hassle that he would be subjected to. And I remember once, this was years later, he showed me a letter, this was after he'd retired, that he'd gotten from Bernd Heinrich, who has done fascinating work with studies of ravens. And one of the journals rejected his work because, it's much too Griffinish.
Oh, no.
There was constant harassment throughout his life. One of the things that so irritates me is that, it's important to have journals for your field. And the Journal of, I think, Animal Cognition might be the name, had the founding essay in it. He,
yes.
Article. And then at what I believe was his 25th anniversary, maybe even the 50th, he's not mentioned. He's not given any credit.
Yeah.
And that's almost, contemporary now. So yes. Okay. So he continues.
I agree. That was part of my motivation in my book on Philosophy for the Science of Animal Consciousness, to really emphasize how foundational Griffin was to the development of such a field of research.
Yeah. When he retired, so-called retirement from Rockefeller, he went briefly to Princeton, and then where Jim Gould, who was a long time, once a student and a co-worker many times with him, and then just retired up as part of the Harvard field station. I think he was part of the School of Comparative Zoology, something like that, the museum. So that's when he did a lot of writing. Many of the books were produced during that period. He was working with many different projects, trying to focus on communication, because he saw that as very important in attempting to understand an animal. And in fact, when asked what caused his switch from being basically a physiology sort of person, physiologist, to animal cognition, animal consciousness, he'd have several answers. Jim Gould was always irritated that when he'd ask him, they couldn't get the same answer. But one very important aspect was the study that by von Frisch and the waggle dance of bees that communicates the location of a food source. Sometimes it's used for a new hive. And Griffin was astonished by that. about what that meant. He didn't use the word, as far as I can find, I've searched around, symbolic at the time. But basically that's conveying information. And it's not like it's rigid. It's not that every bee who is touched by this waggle dance, because there is touching involved, goes off and to fly to the source. Some do, some don't, and not every bee is danced too. So there's a lot of interesting problems that still are stuck in that whole matter. So there's also other sounds Griffin decided might be conveying important information. For instance, desirability of this source. How good is this really, is this thing I'm telling you about? And he entered the field, very complicated field, near field acoustics. There are these, it's not sound exactly, they call it infrasound, vibration, that may be, says Griffin, important in the bees' communication. But to record that is very difficult. And there are turbulent air currents and just what is sensing it. But so that was a field that he was working on with, because, as he said, at this point he didn't have grants. He had a little bit of money that from Rockefeller University still for research, small a bit, and he got, I believe, some small amount from Harvard. But so he was constructing things, as he did his entire life, out of objects around and out of Radio Shack. If I don't think there are too many Radio Shack stores around, but they would give you kind of everyday electronic stuff. I remember visiting him up at the Harvard Field Station in this trailer truck that was his lab with all this gadgetry he was so proud of. Mind you, this started, he invented as a kid, maybe not even a teenager, a carriage, a retractable carriage, which hadn't, been around. So here was the only one in the world for that particular carriage. He fixed his motor of his car, sort of. So he was constructing odd gadgetry, the Griffinberg inventions, as people got to call
them. A very mechanistic mind.
Yes, he did that too, but curiosity about why and how. Yeah. So, but it could likewise construct it. So, so this is going on in these years. He has certainly been influenced deeply, and he's mentioned it in several places, by von Frisch's work. And I think he also mentions how he was struck by the continuing astounding abilities of animals. So he's, and if they can do that, why not more, like thinking, consciousness, basically from an evolutionary point of view? Why should we agree that, hey, there's a similar construction with evolutionary path for chemical interactions, for physical structure, for metabolic processes, even neurons are there, but it's thinking, consciousness, suddenly there's a blockage to thinking. So that was very important in his thinking and why he continued. So he kept working on these matters, the near field acoustics of bees, so complicated, trying with many hours spent on it, with beavers, trying to get beaver communication. Again, I remember going off, and meanwhile his wife would have a certain amount of apoplexy. He's going off in the woods at night, an older man now, he's in his 80s. And once he did, in the winter, badly stumbled and dragged himself back to his car on the ice and snow, and she absolutely demanded that he go out with somebody else all the time. And he mostly followed her, not all, but he was but he loved this. Again, once I went on one, and there were tales of all the tracks in the snow and what animal did what, and we had seen that a rabbit was being chased, and poof, it didn't get caught, it suddenly veered off. The fox didn't get it. So all these tales, he knew many things about nature. Okay, so here we are, still in retirement. So he's still also developing his ideas further, because initially he was very concerned simply, how do I convince other scientists that animals are conscious? Not so much the content of consciousness, which the philosophers were more concerned about. And but by these later years, he was much concerned again, the stuff that had interested him as a kid. What is it like to be such an animal?
Mm.
And he had access to many videotapes with hopes of doing more that Katie Payne, who she and her former husband, Roger Payne, had worked on the famous whale songs, and now she was working with elephant communication. And so Griffin was very interested in trying to understand, say, the communications and how you would set up experiments to explore more deeply what could possibly be the meaning of a particular communication, keeping note of the context, which other animals was around, what had happened previously, and there were many detailed videos that he was working on. I found something that seems maybe to have been a grant proposal. Katie was interested in the conservation aspects. How do you create the best preservation conservation techniques when you know better about what this animal is like, what its needs are, and such. And so this was going to be a joint project. He passed away November 2003. And the other important project was still work with bats. There was a mysterious very rapid buzz bats make right before they catch an insect, and sometimes they make it afterwards, and sometimes it seems like it's being made when there isn't a bat. So there's all these intrigues. Again, part of the mystery. He was convinced for a while that sometimes they were catching insects without this buzz, but that turned out again to be an equipment thing. The microphones weren't sensitive enough. Anyway, so in a very brief format, that's
Oh, I
what.
can see why it took 3 volumes.
Yes, because I also like to delve into the history and bring the work as much as I could up to date. Because it seemed to me if I read something about what bats did according to what Griffin knew, I want to know, well, what do they do? So trying to bring that work up to date was a challenge. I was very grateful for the little physics I still remembered from my undergraduate days as a major in physics.
Yeah, I guess science has progressed quite a bit.
Yes,
Have there been any major discoveries about bats in the last, say, 20 years that Griffin would have been very excited by?
I think the 3D concept of the bat's world is
Mm.
probably the most significant. That whole approach is brand new. Also, there are other suggestions that if they know each other, that seems to be important. Uh, uh, and they're flying nearby, it seems that one bat stops his or her vocalizing and gets the information from the other bat, because you see, you have to worry about the problem of jamming signals
Mm.
and the bat does know which its signal is, given the time and maybe the particular something about it we still don't know. But nevertheless, it's still possible for some jamming to occur. And the other thing is, how do bats in swarms? Jim Simmons is working on this problem and has some very interesting work he's planning to do. I just heard from him the other day when I sent him a link to the book. He was helpful during the writing too, one of the 40 people. Uh, when a bat is in a swarm, how do they still catch insects? Here they
Mm.
all are making these sounds. The insects are tiny. You don't get much reflected back. And you have to be very precise to catch a specific insect. So there are many unsolved solved problems. There's also more work going on in social communication between bats, as opposed to the use of echolocation for finding insects or other prey. Some bats eat fruit. So that would have been, and oh yes, high flying bats. He found in this fun work in Queensland in Australia, well, fun from a scientist's point of view. It was in Chilligo, 5 hours away. Somebody once misappropriated all a significant number of batteries, so he had to drive 5 hours to and fro to get more batteries, that kind of place. And he found evidence of from his kitoons, which are kites with balloons on them that he constructed that you could sort of manage and yet keep aloft, and with microphones on them. So he found that they were very high flying bats. Why are they flying so high? Are you going to find any insects up there? Well, it turns out later, yeah, there are some insects up there too. And one reason might be because of lack of interference from other structures with your echolocation. It's a clear field. So he was also very interested in, could they hear something from the ground? Did that help guide birds or bats, But so now, yes, that has been corroborated. They are very high flying bats.
Yeah, when I was a PhD student in Sydney, I was always amazed by these huge bats flying almost during the day and eating the fruits. From a European perspective, I never got to see a lot of bats in the wild, but they are just hundreds in the sky every evening. It's very impressive.
Yes. In fact, in Austin, Texas, there were, to the people's annoyance, bats flying out every evening all over. Let's get rid of them. But of course, the bat lovers and the other conservationists did not want this to happen. So they managed to get people persuaded at how fascinating it was to watch these bats swarm out. And I remember having been invited to give a talk there. A friend made sure months ahead to get, I and several other people who had come, reservations at a table by the hotel that now had lots of business because you had this great view of the bats, and by them, for whatever reason, we couldn't see them that night. Maybe it was super cloudy, but anyway. So yes, there's a way of talking, and I've seen in India these magnificent swarms of bats that simply cover the skies. And the fact, how now does the mom get back to her baby bat? Because sometimes some young bats, some young babies are carried on their mother, but often they're left back in the cave. And you don't want to, having gone out, danger of being eaten by an owl or whatever else, all these dangers, all this energy to get some food to regurgitate to your offspring. You want to give it to your offspring, right? And not somebody else's, from an evolutionary point of view anyway. And they do it. They think it's partly by odor, partly by knowing the general location, and partly by communication signals. So, yeah, again.
Yeah, I wonder if before Griffin, there was just the sense of bats as vampiric creatures that suck blood, the evil, and that has changed over the years to some extent, at least.
Yes. I know I did not appreciate bats when I came to work at Griffin. I remember it once giving me the opportunity to hold one. I think I didn't accept that opportunity. But since I've engaged in this book, I am fascinated by them. They occupy just about every niche except the extreme north and, cold north, cold south in the globe. They're really quite amazing. So,
yeah, when I was in Nicola Clayton's comparative cognition lab in Cambridge, where she studies a lot of corvids, we saw the same thing where in the past people thought of ravens, crows as being these unholy creatures. The blackness is associated with something morally dubious, and I think we've changed this.
Yes.
Now animal conservation has given us hopes there at least.
Yeah, and that brings up another point about animal conservation. A small section of my book is devoted to the fact of why cognitive ethology is not a major field of study, which it isn't now. But But by the same token, it has had a broad influence, and people now in other disciplines more readily accept that animals have minds, think, are conscious, are aware,
Hmm.
can be hurt. And an important part of all that was funding. In this analysis by a group of researchers looking at the field of conservation and of animal welfare, I guess,
Hmm.
is the proper name. I may be a little wrong exactly what the disciplines choose to call themselves. They were basically dealing with the fact, at essence, that animals are conscious, feeling, sentient beings. But they were framing it in terms of, if you conserve the environment, that's good for humans too. And animals being saved also have the final impact on humans.
Hmm.
If you don't care for bees, you don't get your flowers pollinated, you don't get your food, you don't, on and on. And so they got funding, both from private entities and otherwise. But cognitive ethology kept trying to avoid association with any animal welfare groups, because Griffin in particular wanted to remain objective, wanted it to be perceived, his work
Hmm.
to be perceived as objective, as not having a bias. Oh yeah, you're getting your money from animal welfare groups. That's why you're doing this. He wanted it to be treated from a rational point of view, experimental, and so there wasn't much money. It was
Yeah, I
just
think the animal ethics website or organization conducted a bit of research at some point. I think they interviewed you on this as well.
yes, that's exactly the study I'm talking about. Yeah,
Yeah. Yeah, and I
yes,
suppose even if you just think of ethology, rarely do people now talk of themselves as ecologists. They call themselves animal behaviorists or behavioral ecologists. So perhaps, yeah, the term ethology just isn't as marketable to those
yes,
outside of the field. That might
yes.
be part of the reason.
And I think people doing the same sort of work are eschewing the term because of all the bad press it got,
Hmm.
initially, which is unfortunate. But anyway, that's what would happen. So yeah, let me see if there's. Oh, one thing you didn't ask, but you mentioned crows. And please, if you have something else, direct our
Sure.
conversation there. This is basically some new experiments that I was struck by, that both support theory of mind and
Hmm.
other aspects of consciousness. And one in which also relates to blind sight. Blind sight has been found in humans and experimentally induced in monkeys. And this is where a person has had their brain injured accidentally in certain visual areas. And they claim they can't see anything, and say sometimes it's just half the field. They
Yeah.
can't see anything there, but there they are successfully navigating. They're picking up
Hmm.
things when their other side of the vision is obstructed, so it couldn't be from input from the other eye. And now, so here is sensing without consciousness. Okay, now what about animals? Some people would claim, oh, that's what animals are doing all the time. They're just
Hmm.
sensing without consciousness, if that. And so in these particular experiments, these were done with crows, in which basically we're trying to distinguish between sensing and perceiving. And neurological readings were taken from a population of single units, and I think it's called the nidopalladium, which is a part of the brain that functions in many of the ways that our human cortex does. Our cortex is many layered, has many kinds of connections between those layers and widespread outside it. And so this in birds, though they don't have a cortex, this seems to be functioning that way. And that also gives us insight in, hey, don't, just because something doesn't have a cortex, don't think it can't be, quote, smart or be conscious. And so the crows were trained to peck for a little reward. If they saw a stimulus, a visual stimulus, and not to do anything if they didn't see the stimulus. And in fact, they'd get, if they were incorrect, they'd get longer timeouts and things like that. So it behooved them to be correct because they wanted that little goodie. Now, in the intensity of the visual stimulus, the light would keep being decreased and decreased till it was below what was known to be birds' threshold. And indeed, the birds around that wouldn't peck, wouldn't, and at the light or whatever they were supposed to peck at, and to indicate, in other words, it was saying I didn't see anything. And simultaneously, the recordings showed that there would be, at such times often, there would be a neuronal response initially, and then after a delay, there would be, and by delay, these are very tiny delays, okay? But after this delay, when the bird reported that it saw something, a neuron would then be, the population of neurons would then be producing a second kind of response. And in fact, it was so reliable that the experimenters could predict from this neuronal response whether or not the bird would then say, yes, I saw that, or no, I didn't. So here is a case of sensing, but not perceiving. So I find that quite amazing. There's also some false belief tests conducted with 3 species of great apes, orangutans, bonobos, and chimpanzees. Very complicated, very, very carefully designed, impressive set of studies in which a great ape is behind an opaque screen or a translucent screen. And a human moves a box from one place to another. Now, I presume there's some, as I recall, there's something tasty in that box, so that the chimp would like, or the great ape would like to have it. So the great ape, if you're a great ape that's been behind a opaque screen, you've learned you don't know where it has been moved or which one is it, if that's the way it was designed. Now, they have a human either behind a translucent screen or behind an opaque screen, and they monitor the ape's eye movements. And if the human is behind a translucent screen, and this is critical, and the ape itself or herself or himself has had experience with a translucent screen, it knows its eye movements indicate it's following where the box, the box actually is. Now, if they have had experience with an opaque screen, they, in the interpretation, recognize that the human has a false belief. It doesn't know where the box is going, and so therefore it should be looking at the original place. And by following the eye movements, the ape is looking at the original place. This is interpreted to me, it understands what the false belief of the human is. Now, it's got lots of control, so anything we can probably
No, that's wonderful.
it's incredible. Yes.
When I was in Cambridge, I saw some current research going on where they were trying to do similar experiments with corvids that were caching their food, and they wanted to see how good their theory of mind capacities are. Now, for one, they're using their body, their wings, to hide the fact that they are hiding something. Now, presumably, they wouldn't do this if they didn't think that someone could see them. And then similarly, they used barriers where I think in one experiment they couldn't see through them, but they could hear. And I think the birds were more likely to cache in little containers containing very smooth sand, which wouldn't make much of a noise if you hide them in there, versus the loud gravel. Or in fact, I think one thing that they might have seen is that they were putting things, they were pretending to put things into the loud gravel, but then actually hiding it in the silent sand to mislead. And that's very impressive. It's
Yes,
inducing false beliefs in others, right?
yes, yes. I had the good fortune to do some work with chimpanzees. Unfortunately, not in the wild because they ran away, but it was in a very, very large enclosure. So they did some natural foraging and were
Yeah.
also provisioned. And there was a delightful chimpanzee who, you know, she seemed to be quite smart, and then her behavior correlates with so many things we know about with humans, so that when she was digging a hole, she was digging a hole, well, for whatever reason it was, with a stick. The others would come by to try to play with her or slap her, and and she liked playing with them. She played with them other times, but she was digging her hole and she kept at it. And she would be the one when, as they got older, she couldn't hold her own against some of these great big brute males. And so when there was a goodie like coconuts put out, she would just, if she could hold it for a while, but she would hide it in a tree stump when nobody was looking, only when everybody'd gone away. And so when you see it yourself, it always is quite impressive. Yeah. Let's see, there are a couple of other, I think, experiments I thought were quite impressive, but if you want to talk about something else, we can. The cuttlefish, for instance, which is in many ways a simple, it looks like it's a simple, dumb organism, it, and it, however, shows what, well, comparative psychologists who don't want to impute too much mind and deal in mental states with animals will call it episodic-like behavior. This term derives from the work of Tolving, the psychologist, who, if to have episodic memory, you have to be able to understand that you in the past and what you're experiencing now are the same and maybe projecting into the future. And rather than having these disparate events that don't get connected, usually by this continuing sense of self. So in the cuttlefish, their experiment was related to the famed marshmallow test, in which a little child gets the opportunity for one marshmallow now. Wait, and the time to wait varies. And of course, they're videotaped. You will get 3 or 2 marshmallows later. So it's only around age 4, it seems, but this recent research shows that this also depends on culture and various things that hadn't been investigated, that children are able to do this, not eat delicious marshmallow. Fortunately, nobody gave it to me. I don't like marshmallows, but so in this case, cuttlefish learn not to eat some food that's given to them during the day if they learn that reliably they will be able to get shrimp, their most preferred food, in the evening. So that's an interesting kind of waiting. Mind you, they're hungry all this time. The other experiment, maybe more too, was done, is the cuttlefish is initially given a choice of either none or one. It's in a T maze or a Y maze. A Y maze looks like a Y, and go down the center, and you can branch off right or you can branch off left as a Y is constructed. and it can either, as I say, get no or one, go to the place where one, say, shrimp is, and as a reward, they don't get that shrimp. They get a smaller one later, reliably. Then they are given the situation where there is one of these tempting shrimp versus two, and the value, initially they go for two, of course, but if they've had this prior training where one of these shrimp leads to a reliable, a smaller reward, they, in this one versus two, also go to the one shrimp. So here you've changed the hedonic value of a
yeah, it's very interesting. Long-term
yeah,
planning, delay of gratification.
yeah.
That's incredible in species that we would never have anticipated to show any smart behaviors, right?
Yeah. And it's considered, as I say, either episodic
Yeah, it's
behavior
great
or
to see, even
episodic
from
memory
a
or not.
purely marketing perspective, your book will be interesting not only to those who want to read a biography, but it's really trying to dive deep into any of the areas Griffin was interested in and then synthesizing the latest research on those areas, on all these controversial animal mind capacities.
Yes, I found it very interesting to do. As I say, direct me where you wish, but another thing that intrigued me was going back to what I call, my chapter's called Revolutions. So I look at what was going on in the 70s, not just in how, because it was 76 that Griffin's book, The Question of Animal Awareness, came out. So not just there, but in the fields of, say, physics, biology. And it seemed that it was a time, and also socially and culturally, it was revolutions. There really were big upsets societally. And so I tried to consider the change from behaviorism to the allowance of something like cognitive ethology to emerge, and people to actually at least read about it. And of course, in behaviorism, which had its stronghold for so long, the Skinner's favorite quote, something like, "Give me a child, and I will turn him into," or he didn't say her, "into a fireman chief or a beggar man." And that's what, the behavior quote. You can meld behavior by reinforcement into whatever you desire. Nobody quotes the next sentence, which was something like, "Of course, I'm going beyond and speculating now." I don't have the data for this, basically. He didn't phrase it exactly that way, but that is never quoted, that next sentence. The acolytes just took the hardcore, as it were. But okay, but there were hints. I mean, how do you describe animal behavior without using terms like purpose or want or other mentalistic terms? I remember once, it would have been in probably grad school or maybe even undergrad, having to describe, using no mental terms, the fact that and I'm supposed to be precise, that a rat went around this cage and went to press a bar. Of course, it wanted food. I couldn't say that. How do I describe its movements? I thought, this is bizarre. But back during behavioristic times, there were people like Tolman, who spoke of purposive behavior. He tried to couch it in behavioral terms only, observable behavior, which was impossible because he had this purposeful in there, and he was castigated for that. And yet he, was struck. He couldn't deal with some phenomena without that. Hebb, who's another important psychologist, comparative psychologist, said, look, we need to study mind and self-awareness and consciousness. Another force the Braylons were a couple who had been trained in experimental psychology and were to earn a living. They were training animals to do things that people would pay some money to watch. So, for instance, one thing they tried to do was to train pigs, who we now know to be very intelligent species, extremely intelligent. So to train them to walk and drop a coin into a piggy bank. In other words, there was a slot and it picked up this coin-like thing and dropped it, after which the pig would get a reward. Well, that worked for some amount of trials, but with every single pig, after a while, it would start rooting, which means pushing your snout into the ground and pawing with your paws, because this is behavior that's associated with normal foraging for food that the pigs do. And similarly, chickens couldn't keep still. They'd be scratching in these food-associated situations. And so the Braylons called it misbehaving animals, but said, this is important. You can't just attach any stimulus to any behavior. Each animal, each species has, instinctual behaviors that are going to have to be displayed often. And because there was this division between the American way of approaching science, which was at that point in a lab, good control of the situation. They ignored instinctual behaviors, where there was much more emphasis in Europe about understanding behavior from an instinctual and from a hierarchical level. Now, it even became a sort of cultural, societal negative thing. Oh, the hierarchical, view that Americans held, and so
there's one philosopher, Ruth Millikan, who has a nice quote that nicely illustrates what ethologists were interested in, where she said that a behaviorist studied animals like someone who, or perhaps imagine an alien trying to understand human artifacts and trying to study a washing machine or dishwasher in the ocean. But clearly that wouldn't work. You need to also consider the natural environment for which it has been designed, right? Just as there, you have to think about the place of the artifact. You also have to think about the environment for which these animals evolved their lifestyles.
Yes, absolutely. And another, as I see it, the gradual transition to more cognitive interpretations. I see our timer's running out, so I'll be brief. Was an experiment which I describe in some detail in the book, conducted by Garcia, and the occasion was, as I relate his work, was a discussion that we would have about once a month when I was a grad student at the home of this very elegant professor who lived in a beautiful neighborhood. He was very reserved, very bright. Everybody, whatever their field, would give a paper to him to please read and, make comments about, because he was so analytic. So there would be a topic of a discussion that grad students and the faculty were invited to. And so it was fairly small because who chose to come. About a big issue in psychology, about either technique or more philosophical aspects, or the invited speaker would have an issue. Okay, so this evening, it was supposed to be about Garcia's work, and the normally very civilized discussions got so heated. A very important professor named Richard Solomon, a very nice, generous person, was shouting, literally shouting. One didn't do that in Professor Irwin's apartment, that you're undermining all of psychology, about the results, believing this, thinking this is important. One experiment, one few measly experiment. The experiment was something that Garcia had noted, that when he was conducting some work with toxins, and I think for the military, I'm not quite sure. At any rate, he then gave the rats either bright, noisy water, in other words, a tone and some sound, a clicking sound, a bright light and a clicking sound, say, or tasty water, namely saccharine water. So they could drink water under these two circumstances. Rats, and then they were given something that would make them nauseous. It wasn't immediate that they'd get nauseous. And lo and behold, the next time they were offered water, if they had been offered if the conditioning had happened with the bright, noisy water, they just went and drank the water. But if they had become nauseous after they'd drunk tasty water of some taste, they would avoid the water. Now, this supposedly, any stimulus should be associated with any response, that's a law that pertains to all creatures. That's why we study rats. They're simple, but the same laws apply to humans. Then he did it even more. According to the same law, the time between the two stimuli, between the tasty water and the nausea, should or any stimulus you're conditioning should be, the briefer it is, the more potent the association is. 1/2 second is optimal, supposedly, in there, some form of some stage of the theory. But the next set of experiments, he gave basically the same scene, but gave apomorphine, which immediately induces nausea. And he could delay up to 3 hours the stimulus, say the tasty water, and the giving of the apomorphine, and the rats could still learn to avoid that water. So this was, by some, like people like Paul Rosen in the department, was considered to be extremely important about all of psychology. It turned it belongingness. Certain categories of stimuli belong together, will be easily associated with other ones weren't. And it's a general phenomenon, I think called it a general adaptational principle. So that was another, I think, very important development in the slow change from behaviorism to more cognitive. Robert Ristau did work, again, he was a student of Richard Solomon's, in which what matters according to the theory is the number of pairings, say, between the CS and UCS, as it's called, a conditioned stimulus, say a sound, and unconditioned, say, shock. So you use dogs for this. So he paired exactly the same number of times in one set of occurrences between these two stimuli. And then in another, he had the same number of times, but also sometimes the CS, the tone, wouldn't lead to a shock. And the animals should have the same strength. What matters, theory, is the number of pairings. That's what matters, says the theory. But it didn't. And the association was much less strong if there were also times where the stimulus lost its predicted value. And that's how we interpret it, not just an association, blanket association, but rather information that is being conveyed, predictive value. And so that's a new way now of looking at these classic reflexive models that were modeled after the notion of a reflex. And then came the rest. Ulrich Neischer's book on cognitive psychology, Griffin came.
Right. No, it's interesting to think about these scientific revolutions, and now there's less and less, at least initial skepticism towards also studying the subjective experience of animals. I'm running a bit out of time, so I'll have a last question for you, which is, why did you decide to write this book? And perhaps you could tell us a bit about your personal friendship to Griffin there as well.
Okay, I decided to write it because I was so irritated that this man who'd been hassled and hassled, I mean, even, I don't want to get melodramatic, but even as he was dying, He had written a paper that the last 2004, I think, is the publication date. He and Gail
Yeah, I
Speck.
think in animal cognition.
Yeah, and it was being sent over and over back to him. There'd be long delays because he had they didn't like the mentalistic terms, basically. Okay, so finally they accepted it. This is a rumor I heard. Somebody actually told them what the scene was, and come on, get it done. Accept it or don't accept it. Do it before the event, Don's passing happened. So I was angry about how after all this stuff, he, like that publication anniversary where he's not mentioned. And so many papers I read that it seems to me he should be there in the bibliography. He's not. But by the same token, his work is, far more important. I don't think my book is going to make his memory, and his work really get much more traction. So that was it. I saw that many of the people who could give information about all this were passing away, and some did during the course of my studying, and some I didn't get to. And that was happening. I had access to some papers, and I didn't know, what would happen if they weren't dealt with. So those are the kinds of reasons. I very much was impressed by him. I was as I say, I knew him first actually as that strange man at the other end of the cafeteria at lunchtime, who, when the weather was absolutely miserable and gloomy out, he and a bunch of grad students would be he'd be smiling and saying, "Oh," rubbing his hands. That was a favorite thing, and he was delighted because, in fact, the experiments he was conducting at the time were to try to get information about whether birds flying through intense cloud, so they couldn't be guided by either the stars or anything on the ground, could nevertheless home. And so that's how I first saw him. I was suggested by Peter Mahler that I work with him, and I did. So I knew him then. He was very supportive in my own research work with plovers and looking at possibly purposeful behavior that they exhibited. And as I said, lent me his sailboat, not his boat, which I didn't treat properly. And so I became, endured an occasional. I mean, he and Jocelyn were all the way up in Massachusetts, but often when he came to the city, we'd all have dinner together, or I were passing anywhere near, I'd make a detour and we would stop by. We'd all have dinner there over the years, and sometimes more, sometimes less so. But near the very end of his life, I had more contact again with him. So, yes.
Yeah. No, thanks so much for all this information. Maybe this will be the longest podcast episode I've recorded yet. So thanks so much for coming on.
Well, you're very welcome. Thank you for having me. I was terrified about having to deal with deep philosophical issues, but you didn't. Even though I have a chapter
Maybe we
about
need
that.
to schedule another episode at some point. Yeah, so for the listeners, I'll put the link to the book into the show notes.
Great. I do have one here.
Wonderful. Yes.
Okay, I don't know.
It will be there as well. And yeah, it's open access. You don't have to pay for it, so should be very easily accessible.
Yeah.
I'll probably download it and try to listen to it via one of those new AI into text into speech apps. They're pretty useful. Maybe on a bulk.
I was wondering about them. Don't they sound deadly?
They have become much better.
Oh, good. Okay.
You can pick like, but at this point they have hundreds of voices and some of them sound quite human. But yeah, probably not as good as an actual human reading it out. Anyhow, thanks for watching this episode. I'll see you again.